today I'm going to show how we decompose the price effect into an income and substitution effect. Now, in order to uh, undertake this analysis, we require some advanced mathematics which you have not covered. So first I'm going to briefly cover these aspects. You will get the details in the next semester when MD will cover constraint maximization. Okay. Now we know that any agent consumer maximizes utility. Let us say his commodity bundle comprises of two commodities, X1 and X2. So his objective is to maximize utility subject to a budget constraint, which is given by expenditure, so P1X1 plus P2X2, and this expenditure is equal to his income. Now this is a maximization exercise in two variables, and you also have a constraint. Okay, now you know how to graphically find out what is the equilibrium condition in this case, but in order to find out this condition mathematically, we need to generate what is called a Lagrangian function, and then we try to maximize this. So this entire information, maximize utility subject to a budget constraint, can be written in this form. First we write the function which is going to be maximized, and then we write the constraint. Here lambda is called the Lagrangian multiplier. So this function has to be maximized, and in this form it's no longer a constraint maximization, it's simply a case of maximization with multiple variables. And what are the variables that have to be chosen in order to maximize the function? We have three variables, X1 and X2. You can realize that these will come. These are the choice variables, but lambda is also treated as a choice variable. So that means we have to take three differentiations. We have to differentiate this function by the three variables. Necessary conditions. So this implies we are differentiating with respect to x1. So we are going to have del u by del x1. The lambda comes over here. We treat all the other variables as constant. So the lambda is over here, and x1, del x1 by del x1 is 1. So we have minus p1 over here. So we can write this as u1 minus lambda p1, and this is equal to 0. So similarly, the other two functions are u2 minus lambda p2 is equal to 0, and in the third case it is n minus p1 x1 minus p2 x2 is equal to . The second order conditions are written as follows. This is in terms of a matrix. So u11, u12, and obviously these are the second derivatives. This is u21, u22, and then we put in minus p1 minus p2, and this is 0. This is called the bordered Hessian determinant. Why bordered? Because you can see there's a border over here. This last row and last column are the same. Minus P1 minus P2, minus P1 minus P2, and this is 0. So if you are trying to maximize the function, then the bordered Hessian determinant, we call this H, alternates in sign. So that means, let us say, if this is positive, then this implies that Hn plus 1 and also Hn minus 1 both will be negative. Okay, so basically if you have a positive matrix, you increase the number of choice variable, it becomes negative. You increase the number of choice variables even further, it becomes negative. It becomes positive. Okay, so the let me state the precise form of the of this condition. In case of a two variable, so in fact we write this like this. In case of a two variable bordered Hessian, this is supposed to be positive. So that means the third order bordered Hessian will be negative. H4 will again be positive. Okay, is it clear? Okay. So this is the background that you need to know before we start the decomposition of the price and income effects. Okay. We require this information, and secondly, we will also apply the chain rule. So let us create the slides. So what we are basically going to do is, now that we have found out the objective function, the first order conditions, we are going to derive the demand curve, and then we are going to examine the impact of a change in price. So we have a set of conditions. u1 minus lambda p1 is equal to 0, u2 minus lambda p2 is equal to 0, and if we just rearrange the terms of the last constraint, the budget, you will realize the third constraint is the third maximization condition is simply the budget constraint. So we have three equations and we have got three unknowns, x1, x2 and lambda. So if we solve this system, we are going to get x1 as a function of p1, p2 and m, the three parameters, prices and income. x2 is a function of p1, p2 and n. And similarly lambda, the solution value of lambda, in fact all these are solution values, so let us put in stars. So this is also a function of prices and income. Okay, and just if we divide 1 by 2, we get u1 by u2, and this is p1 by p2. So this is the ratio of the marginal utility. So mu of with respect to x1, this is mu with respect to x2, and what we are getting is prices. Okay, so you realize that this is simply the mathematical derivation of what MD has discussed in the consumer equilibrium problem. Now, the problem that we want to look at is that we have these will give us, in fact the first two gives us the demand curves. So we have the demand for x1, the demand for x2. Now the problem is that suppose the price of any commodity changes. Let us say P1 changes. How will this affect demand for some commodity? So this is the question. So first what we are going to look at is that if P1 changes, how will this affect X1? So we are looking at own price. And you know that if from the law of demand, we know that the answer to this question is that if P1 increases, then X1 will fall. If we look at cross price, so P1 changes and we want to see what happens to, let us say, X2. So this is the cross price effect, and the answer to this will depend upon whether X1 and X2 are substitutes or complements. If they are substitutes, then an increase in P1 will mean that X1 is going to go up, and if they are complements, then an increase in price P1, sorry, this should be X2. An increase in price means that X2 will decrease. Okay, so this is a positive relation, this is negative, and you know that the own price is negative. So this is something that we know. Now what we want to find out, or rather what we want to show, is that, see, what this is, we call this the price effect. And we want to show that this price effect can be split up into two parts. One is the substitution effect, and the other is an income effect. You know what these two effects are. MD has covered it. The substitution effect is simply the change in the relative prices. So one commodity becomes cheaper with respect to others, which this will lead to substitution between the two commodities. And the second is that when price increases, your real income changes. And when real income changes, then this will lead to a change in demand. So this is substitution between x1 and x2, and this is real income has fallen. If price goes up, the real income falls, and this will lead to demand for both commodities decreasing. Okay, so now we are going to show how the price effect is going to be decomposed. Let us see. Yeah. So this decomposition was first undertaken by the Russian statistician Slutsky. I don't remember the year in which he published a paper, roughly I think in 1905. Circa means 1905. So it's written as C dot also. And subsequently, he derived a mathematical definition, and as you know that the graphical definition, the intuitive definition was subsequently modified by Sir John Hicks. The definition, when Hicks derived the decomposition, he used a different definition of the income effect. I'm sure Indy has covered this, but basically the Slutsky definition was the Slutsky income defined constant real income in terms of utility. So you're on the same indifference curve, and Hicks defined constant real income in, sorry, it was the opposite actually, if I remember correctly. Hicks defined real income in terms of utility, and Slutsky defined constant real income in terms of the original commodity bundle. So that means you have to be given a real income which enables you, you have to be given a money income which allows you to purchase the original commodity bundle, while Hicks definition says that you have to be given a real income so that you are on the same original indifference curve. Anyway, this part is not very relevant. What is important is that we are going to cover this Slutsky effect. Now, when we are going to do this decomposition, we are going to assume a 3 commodity world. Why 3 commodities? Because 3 commodities in the results that you obtain in a 3 commodity world can be generalized more easily. So that means the maximization problem is utility is a function of x1, x2 and x3 subject to p1 x1 x1, p2 x2, p3 x3 is equal to n. So the first order conditions will be u1 minus lambda p1 is equal to 0, u2 minus lambda p2 is equal to 0. This is for the third commodity, and finally you have the budget constraint. So these are the first order conditions. The second order conditions, which is given by the bordered Hessian, look, it is H3. So therefore it will be negative. Okay. Now what we are going to do is we assume that P1 changes. Okay. Now let us look at how we differentiate. And remember that we have got 4 variables, x1, x2, x3 and also lambda. Okay. Now when x1, see, over here this is u1 is the marginal utility with respect to x1. So when x1 changes, u1 changes, right? So this is, we write this as u11. Sorry, we said that P1 is changing, right? So when P1 changes, remember that what we have obtained over here is the demand curves, and the demand curves are functions of P1, P2 and M. So when P1 changes, then x1 is going to change, and when x1 changes, then u1 will change. Okay, just one change. This will be, these are not the partial but the actual derivatives, dx1. Okay, then we have got lambda and p1. Okay, if p1, first let us assume that lambda is constant. So if you are differentiating with respect to p1, we simply get lambda. Third is, lambda itself is a variable. Okay, so that means when dp1 changes, then d lambda will change. Okay, so when price changes, lambda also, remember, lambda also is a function of prices and income. So when p1 changes, lambda will also change. So now we hold p1 to be, this p1 will be constant. Okay, and this is equal to 0. So we write this as this will be U11. Sorry, I've made a mistake over here. Let me redraw this. Yeah. Okay. When P1 changes, let's see what happens. See, this is X. This holds for I is equal to 1, 2 and 3. Okay, so when P1 changes, X1 will change, X2 will change, X3 will change, and lambda will also change. Okay, okay, now let us look at U1. Okay, so what we have to see is that when X1 changes, how does U1 change? When X2 changes, how does U2 change? How does U3 change? Okay, because in this utility function, U1, the marginal utilities will have X1, X2, X3. Okay, so in that case, what happens is P1 is changing. As a result of this, X1 changes. Sorry, this will be X1. This is U1. Then P1 changes. X2 will change. We are talking about this effect. So X2 has changed. This will lead to a change in U1. Then X3 changes. Okay. So similarly, when P1 changes, then sorry, this should be D. Let me make it D. P1 changes, X3 changes. So when X3 changes, again U1 will change. Okay, so X1, X2, X3, we have captured this part. Now we come to the minus lambda P1. First we hold lambda constant. Okay. So if you hold lambda constant, in that case, lambda and del P1, it is simply dP1 by dP1, which is equal to 1. Next we hold P1 constant, and we want to see what happens if P1 changes. From this function we can see that lambda will also change. And the right hand side is 0. So this will be U11. It is dx1 by dp1. This will be the cross partial derivative d12 u12 into dx2 by dp1. Then we have got u13 by dx3 by dp1. Okay, now this is minus lambda. We take minus lambda to the right hand side, and this is P1 okay. So let us write this over here. And this is equal to lambda. Okay, so again I made a mistake. Okay, Now let me shift this a little bit. Okay. So what we have done is we have differentiated this equation. Now let us come to this one. Remember U2, this is simply the marginal utility, so U2 will also may have x1, x2, x3. So if we differentiate this, what happens is, when price changes from the demand function, x1 will change. Now instead of del u1, we have del u2. So this becomes u21. So remember, it's always 2. This will be u22 del x2 by del x1, and this will be ut3 del x3 by del p1. Now we come to the lambda p2 part. Okay. So a little part we just got. Now P2 is a constant, so if P1 changes, P2 will be unaffected. So wait a minute, let's not write this. So what I'm basically saying is that dp2 by dp1 is equal to 0. Okay, so that means over here dp1 by, we have taken dp1 by dp1, now it is dp2 by dp1. Okay, so this term will vanish. So we have minus 0, so we are taking that over here. So only the corresponding term of this will remain. So we have p2 d lambda by dp1, this is equal to 0. Okay, so it's basically a rewriting of this. Only the right hand side we have the lambda, because lambda into dp1 by dp1, this term is becoming 0. So let me write this now. This is, all this will be u21. u22, this will be ut3. But the differentials are the same. So you can see that a linear system is being generated. If this is our axis, the unknown, what we want to find out. Right? This is equal to 0. Sorry, there's an error over here. Right? Now let us look at u3. In the same way, this will be u31 dx1 by dp1. So this part is the same. Okay, then lambda p3. So minus lambda this is equal to 0 and also minus P3 d lambda by dP1 equal to 0. So this part disappears and we have, this was minus P1 into d lambda by dP1, this is P2 into d lambda dP1, this is P3 d lambda dP1. So it becomes U31, I'll write these terms later, plus U32 and this is U33. Okay, and this part it is lambda minus P3 d lambda by dP1 is equal to 0. Now we have this term remaining. Minus P1, etc. So let me just remove this part. Minus equal to 0. So let's differentiate with respect to P1. Now remember M is a constant, so this is 0. Okay. Now P1 we have dx1 by dP1. Okay, x1 is a function of P1. We have this. But at the same time, if we keep x1 over here, we also have dP1 by dP1. Okay. So in a similar way, we can write P2 dx2. Let's put this in bracket. This is dP1 so I better put plus because I've taken minus 1 common. Okay, now this is x2, this will be dP2 by dP1 and we know that this is equal to 0. Okay, so that means only this term will remain. So there's actually no point in writing this part. Okay, so in the third term, when I'm writing, this will be P3 dx3 by dP1. Remember that we are also going to have this x3 dP3 by dP1. This is x3 into 0. Okay, so we need not write this part. Okay, and this entire thing is equal to 0. Okay. Now this is 0, remember, m is a constant. Okay. Therefore, we have got p1 dx1. I'm just bringing all the terms. I'm not writing this. This is p2 dx2 by dp, and this is, okay, then this is minus. I send this to the right hand side so that I get, sorry, dp1 is 0, so this is 1, this part is 1, so it's just x1. This is minus, it becomes positive. Okay, so what I get is minus p1 minus p2 minus p3. Here I don't get any d lambda or dp1, so the coefficient is basically 0 over here. So let me write this. This is x1 and this is dx1 by dp1 dx2 by dp1 dx3 by dp1. Sorry, I've written p3 over here. Actually, it's very monotonous. Okay, so this is the equation system that we have over here. This is the equation system that we want to solve. Okay. Right now, now you can see that this is a linear system. The column, this multiply dx1, this is same. So what you get is a linear system like this. And this is 0. Okay, so this is dx1 by dp1 dx2 by dp1 dx3 by dp1. This is d lambda by dp1. this is equal to lambda 0 0 x1. So this is the matrix that we have, and we can use Cramer's rule to solve this equation system. According to Cramer's rule, we have dx1 by dp1. Well, you have two terms over here. The numerator, which I am going to look at later. The denominator is the A matrix. Now, if you look at it carefully, this is simply the bordered Hessian determinant. Of order 3, and this is negative. Okay. Now let us look into the numerator. Okay. So the numerator, we have to replace this term by the first column by the C matrix, C vector. So we have 1 2, this is 1 3, this is 2 2, this is 2 3, this is 3 2 and 3 3. We have got minus p2 minus p3, this is minus p1 minus p2 minus p3, and this is 0. Okay, so this is lambda okay, let us see. If I drop lambda, it is u22 u23 and this is minus p2 minus p3 0. This is plus minus, so this is x1, and x1 is equal to this is minus p1, this is u22 into u23 minus p2, this is u32 . Okay. Now, if you look at it carefully, this is simply the bordered Hessian when the consumer is commodity bundle comprises of two commodities, x2 and x3. So it is simply h2. Okay, you have x1 and you have this determinant. Okay, which we are coming to later. Okay, so remember that in this numerator we have dx1 by dp1, so the numerator comprises this term. So what we have is a term like this, minus lambda, this is h2 and this is h3, minus x1, you have the unknown matrix. I have not named this, given any name. Okay. Right. Now la lambda, and this is, remember, H3 is negative, so H2 has to be positive. Right? So that means this is the substitution effect, and you can see that the own price substitution effect is always negative. So we have derived the substitution part. Now we have to show that the remaining term will be the income effect. So we are interested in this term. Don't need this part, so this is what we are, this is the residual term. So let's just mark it over here. That was very badly done. So this. Okay. Now let's go back to the first order conditions. U1 minus lambda P1 is equal to 0. U2 minus lambda P2 is equal to 0. U3 minus lambda P3 is equal to 0. And M minus P1 x1 P2 x2 is equal to 0. Now look, what is the income effect? Income effect is there's a change in income, and this will lead to change in demand. So we are concerned with x1, so it will lead to a change in x1. So basically what we are interested in is dx1 by dm. This is the income effect. Okay, now remember that what we had said was x1 is a function of p1, p2, p3 and m. So also x2 and x3. Right. Okay, so let us say that m changes. So if m changes, x will change, and this will lead to a change in utility of 1, u1 to 1. So similarly, we can find out we have u13 dx3 by dm. Okay, so now we have lambda p1. Okay, now lambda is also a variable. So we have d lambda by dm. And what about the price? We keep lambda constant. dp1 by dm equal to 0. Now prices are constant. So that means this will be 0. So in the same way, we can differentiate the second first order condition. We are differentiating this. Right? There's no point in writing this. P2 by dm, this will be 0, so it's equal to 0. u31 dx1 by dm, this is u32 dx2 by dm, u33 dx3 by dm, this is p3 d lambda by dm, and this is also equal to 0. Okay, now let us start with this minus p1, p1 x1. So this is minus p1 dx1 by dm minus p2 dx2 by dm minus p3 dx3 by dm. There is no lambda over here, so let me put a plus 0. Now we have m is over here, so we have 1 over here, and this 1 can be taken over here. Okay. So what is this dx1 by dm? It is simply you will see it is basically the same term, or almost the same term. Sorry, this is actually what I'm writing is the numerator. Let me finish writing it, then I'll change it. Sorry, let me. So this is the numerator. The denominator will be, we remove this and we put in 000 and minus 1. So okay, so this is no, let me Just hold on for a minute, please. Okay. So if you break it up, then this is minus, this is plus, minus, plus, minus. So it is 1. We have to remove this. So it is U12, U1 3 minus P1, U22, U23 minus P2, U32, U33 minus P3. And this is H3. Okay. Now look at the residual term. U12, U22, U32. This is exactly what we have. U13, U23, U33. Right. P1, P2, P3. Right. And divided by the third order bordered Hessian. So that means the residual term is minus x1 dx1 by dm. Okay. So the price effect, which is dx1 by dp1, is equal to lambda. This is the bordered Hessian of order 2. This is the bordered Hessian of 3. This is minus x1 by dm. This is the Slutsky decomposition. So Let me remove the parts which I don't require. And the general form is dxi, this is equal to lambda So this is the substitution effect and this is the income effect. Now note 2 points that we know that the bordered Hessians alternate in signs, so this is always going to be negative. And the other term is that if you look at the income effect, for a normal commodity, this is positive for a normal good, but the income effect is equal to is xj del xi by del m. So that means this is positive and for a normal commodity this is positive. So what is the income effect? It is negative. So the price effect is the summation of the substitution and income effect. Both of them are negative and therefore the price effect will also be negative. This is equal to substitution effect plus income effect. Both are negative, implies that the price effect is also negative. Of course, we are assuming that they are substitutes, one, and secondly, they are normal commodities. Okay, so this is the substitution, decomposition of the price and substitution of the price effect into income and substitution effect. References. Well, I mean, you have Hicks's value and capital. I mean, I've taught this from value and capital, but I think Chiang also has a similar definition. Yeah, you can look at a 378 onwards. My own favorite from where I have taught is Chiang and Wainwright, but you can also go for Chiang.